Section 5.4, number 27. A total of 1,020 tickets were sold at a football game. Adult tickets sold for $1.50 and children's for $1. If a total of $1,340 was collected, how many adults bought tickets? First thing I want to understand that this is a ticket problem, and for ticket problems, we are going to want to make a chart. So I'm going to start by writing the chart out. The next thing we'll do is label the chart. Since this is a ticket problem, we're going to start off with the type of ticket, the number of tickets, the value of a single ticket, and the total value from that ticket. Now remember, whenever we're trying to do ticket problems, we always remember that the number of tickets multiplied by the value of a single ticket will give you the total value from that ticket. So I'd like to also label the type of ticket as adult tickets and children's tickets. Now, before we move on to writing an equation, we want to make sure our chart is completely filled out. Keep in mind that the equation is going to come from the total value column. So before we're able to fill out the total value column, we're going to either have to fill out the number of ticket columns first or the value column first. And I always go with what I think is the easiest to fill out. And I believe the value of the tickets are actually given to us, so that's the first thing I'm going to fill out. So let's see, the adult tickets are sold for $1.50. So I'm going to write that in. And the children tickets are sold for $1, so I'll also write that in too. Now, the next column, number of tickets, is going to be a little more challenging to fill in. And so to understand this, we're going to try to come up with some concrete examples to see if we can fill out the number of tickets for the adult and number of tickets for the child. Let's see, let's look at this a little closely. We're going to understand that there's a total of 1,020 tickets. This consists of the adult tickets and the child tickets. So a lot of times what I like to do is come up with a concrete example. If I know I have a total number of tickets as 1,020, I'll try to make a quick chart dealing with the number of adult tickets and the number of child tickets. And they didn't specifically say how many adult or child tickets we have. I don't know if they're evenly split up, so I can't call them exactly the same variable. All I know is that the problem is asking for how many adults bought tickets. So maybe what I want to do is come up with something that I might understand. So let's suppose that there were 20 adult tickets sold. That would imply that there would be 1,000 children tickets. Let's suppose that there were 10 adult tickets sold. Then that would imply that there'd be 1,010 children tickets. And I'm trying to figure out how am I getting the number of children tickets if I know the number of adult tickets. So I'm going to do one more example because I'm not quite sure. So if there were 1,000 adult tickets sold, that would imply that there are 20 child tickets sold. So eventually I want to figure out if there were a adult tickets sold, what should I be writing in for the number of children tickets? So I'm going to develop this just a little bit further I want to ask myself if I knew that there were 20 adult tickets and there were 1,000 children tickets. I want to figure out how did I get the 1,000? And that happened to be taking away from 1,020 and subtracting off the number of adults. And I believe that's the same thing for each of these expressions for the number of children tickets. So I'd like to develop a pattern in order to see the expression for number of child tickets. I'm going to notice that the first number in every expression is 1,020. So I'll write that down. I notice that there's a minus sign in between the numbers. Write that down. And I notice that the last number, it's varying. And that last number depends on however many adult tickets we have. So the expression for number of child tickets should be 1,020 minus A, the number of adult tickets. So I'm going to fill in my chart. So the number of tickets for adults, we're going to call that A. And the number of tickets for children, we're going to call that 1,020 minus A. So now we're ready to find the total value column so that we could actually set up our equation. And how these problems always work is you're going to always multiply the number of tickets times the value of a single one to get the expressions for the total value column. So the expression for the total value of adult tickets is going to be $1.50 multiplied by A, and the expression for the total value of children tickets is going to be $1 multiplied by 1,020 minus A. So the neat thing about this particular column is now we are ready to set up our equation. Our equation comes from adding the total value of adult tickets plus the total value of child tickets to equal the total value of all tickets. So if we look at what we have in our column for total value, the total value of the adult tickets were $1.50 multiplied by A. And the total value of the child tickets would be $1 multiplied by 1,020 minus A. That is going to equal the total value of all tickets, and the word problem tells us that a total of 1,340 was collected. So the next thing we're going to do is solve this equation. And if we remember how to do that, we want to make sure we simplify each side separately. So the 1,340 doesn't have much to go, but we need to figure out how we're going to simplify this left-hand side. And the first thing in the equation solving strategy tells us to get rid of parentheses by using the distributive property. $1 times 1,020 will give me $1,020. $1 times negative A will give me negative A. I'm going to rewrite the plus sign that was already there, as well as the $1.50 multiplied by A. I'll also bring down the equal sign and rewrite the 1,340. The next thing we will do is see if we can combine like terms on the left-hand side. And I notice that $1.50 and negative A are like terms. So if we actually combine them. We're going to subtract $1.50 minus A, or that would be minus 1A. Write that in to help. So $1.50 minus 1 is 0.50A. We still have an addition sign with a 1020 to equal 1,340. We will subtract 1,020 from both sides. So that the 1,020 will cancel out on the left. We'll be left with 0.50A on the left side. And 1,340 minus 1,020 will be 320. So to finally solve for A, we will divide both sides by 0.50 to get A equals 640. Remember, if you're using your calculator, you're always going to want to punch in the 320 first, the division key, and the 0.50 second to actually get the correct answer. So the last thing I want to do, I understand I've solved my equation, but I want to make sure that I'm actually solving for what the problem wants and to see if this actually makes sense. So if I remember correctly, A stood for the number of adult tickets sold. So having it be 640 tickets, that will make sense. The total number of tickets was 1,020, so it's a less than 1,020. So I reason that that's a reasonable answer. So I'm going to summarize that on the side. As far as the adults, we have 640 tickets. Always remembering to put the units on my answer. And if I read the problem one more time, I want to make sure I'm answering everything it wants for me. So I read it one more time. A total of 1,020 tickets were sold at a football game. Adult tickets sold for $1.50 and children's for $1. If a total of 1,340 was collected, how many adults bought tickets? And it looks like I've already answered that question. There were adults, there were sold 640 tickets, or you could also say that there were 640 adults.